Hi, these are all examples of digital multimeters or DMMs, and we're going to take a quick look at what these are and how they work, what they're useful for. Let's go. And they come in all sorts of shapes and sizes, from little pocket ones like this to like smaller compact ones to ones your electricians might use to larger ones that you might find in a higher end electronics lab. And they can vary in price from $2 right up to like $700-800, something like that, for like a really advanced big brand name one. Regardless of the type you get, they're all going to be basically similar. They're going to have an LCD display on them, typically with 4 digits for your lower end ones. Your higher end ones might have 5 digits. They're called counts. And what the number of counts on a multimeter means is just the maximum value it can go up to on the reading. This is a 6,000 count meter, so it'll go to 6,000 maximum, or 6.000, and this is a 3,200 count meter. So if I turn the voltage up here, they can both measure the same number of digits at 3.1 volts and at 3.2, but if I go to 3.3, you'll see that this ranges to the next range and you lose a digit. So the more counts, the better. And most of them will contain a selection dial like this. So you can select, turn it off, and you can select various different functions, hence the name multimeter. It has multiple functions. Although there are a few others like these two here that don't have a range switch. Instead, they have push buttons on the front. But personally, I'd go for the ones with real range switches like this, because you can just switch them off. You know they're off. It's much easier than mucking around with these push buttons. And really, don't go for any that have built-in rechargeable batteries like this, or ones with backlit displays like this. They're just not worth dicking around with, really. All of them have backlights, by the way, so you can actually use them in dim environments. So don't get one of those. Just choose battery power. Just don't dick around. Range switch all the way. Now, digital multimeters come in two main types. One is auto ranging and one is manual ranging. You'll notice this has a lot of switch positions, and DC volts, for example, it has different ranges. So this is 1,000 volts DC range, 200 volts, etc., down to 2,000 milli, which is 2 volts, and 200 millivolts. Whereas in auto ranging meter, you just select DC volts and then it automatically changes the range for you. And I really don't recommend these manual ranging multimeters. Just avoid them. They're very old school, and you have to know which range you want to be on, and if you get it wrong, it can overload the value on the display, and they're just not worth mucking around with. It's much easier to get an auto ranging multimeter. You just select the function you want, and then it measures the correct range automatically and displays the value you want. No mucking around. But if this $2 manual ranging multimeters all you got, it'll do the job. It'll get you out of trouble, but otherwise, nah, don't bother. And they will all come with insulated multimeter probes like this, which these are called banana jacks, and they plug into the sockets on the front of the multimeter, and they have a very sharp metal probe tip on them with insulated handles like this. And this little finger guard on the probe here, that just prevents you, when you're probing things, it prevents your fingers sliding down and accidentally making contact with the metal, and if you're measuring high voltages, that could be dangerous. And some, like these pocket multimeters, actually have the probes permanently attached. And some of them might have a rubber protective outer pouch like this, which you can remove. That's just protection in case you drop them. And some other ones might have an integrated molded rubber which you can't take off. And they'll run from batteries, either AAA, AA, or a single 9-volt battery, and you'll typically get a couple of 100 hours permanent use out of them. And almost all of them will have an automatic power off timer if you forget to turn it off, like 5 or 10 minutes or something like that, but you can manually switch it off. So what is a multimeter? Well, it basically contains multiple different instruments in one, and it's designed to measure multiple electrical parameters like voltage, resistance, and current. So it has the functions of a voltmeter, which measures both AC and DC voltage, and you can see that AC and DC there, or you can get the symbols like this with the bar across with the little dashes, that means DC, and the little sinusoidal wave there, that means AC. And they also have an ohm meter built in, which measures resistance in ohms, and that's the Greek omega symbol, which you'll see up there. And the third major function is an amp meter, so you switch it over to A. It also has MA, which is milliamps, or mu A or UA, which is microamps, and that measures electrical current in amps. But not all multimeters measure current, like this Fluke 101 here, and it only has 2 input jacks, although you can actually get multimeters with 2 input jacks that do measure current as well. But usually how you identify them is they do actually have an extra 3rd or 4th jack here, which has A or MA or UA on it. But current is not something that your average beginner or home tinkerer or home handyman is going to want to measure. So it's perfectly fine to get a multimeter that doesn't have current measurement or that amps position on it. Something like this is just fine for most users. So they're the 3 basic functions of a multimeter, but most multimeters these days actually have a bit more functionality than that. You can have, for example, capacitance measurement, which is this symbol over here, and that's useful for a few things, but more electronics engineering related useful than like something you might use in your home, but it could come in handy. I'll show you that in a minute. And capacitance is measured in farads. You can see that F symbol up there. The N in front just stands for nanofarads. They're different units. We'll have to mention that later. And another very handy function is called continuity, which is this like sound symbol here. So you can typically switch modes like this and go, you'll notice the sound symbol up there. And what that does is it will beep, and this one even flashes. It'll beep if you've got continuity in your circuit, and that's very useful for measuring breaks in any sorts of cables. And that's very handy for quickly trying to find where connections are going on your PCB. For example, you can just drag your probe along very quickly and can see that, oh yeah, those 2 are connected to this point over here. Very handy. And there's some people who think this is one of the most important features of multimeter, so much so that you should get a good one, because they do vary. A little pro tip here, if you get one and you really do fast like that and it responds very quickly, instantly, and it latches like that, then that's a good continuity tester. But you can get ones that have a very laggy response and they're not very good. You just can't drag your probe as quickly across as you could with a really fast acting response one like this one. The other function is called diode testing, and that's that little symbol that shows up there like that. And the diode function allows you to measure the voltage drop of diodes in circuit, which is typically 0.5, 0.6 volts like that. So that's very handy for electronics troubleshooting. And one handy feature of diode testing, not only for regular diodes in circuits, for example, but also LEDs, because that stands for light emitting diode. So you can actually test those, and you can see probably it has enough brightness there just to light up a white LED here. Not all multimeters can do this because it varies based on the type of battery installed, the maximum output voltage on your terminals, and the output current that it's driving through the LED. But most multimeters should be able to at least light up LEDs, and that's a handy little feature. And another very handy feature of some multimeters, they come with what's called a thermocouple, which is a temperature sensing probe. It's got a little thermocouple tip that can measure the temperature of anything it comes in contact with. Physical air or metal to measure heat sink temperatures, or water, liquids, or whatever. And that's that little thermometer symbol there. So you switch that on. Degrees Celsius here in Australia, thank you very much, but you can select Fahrenheit as well. 29.5 degrees Celsius, and if I put my fingers on that, of course, my body temperature is going to cause that to go up. Very handy feature for lots of different uses. Sky's the limit on that one. And some meters might have a handy function called electric field testing, typically EF, like this, and you press EF, and this allows you to test the presence of mains voltage. There it is. If you get it right close, there's a sensor up in here, and as you get close to an energized 240 volt or 110 volt cable, it'll show up. Pretty handy. And there's some other features like measuring frequency in hertz, for example, like your 50 hertz mains voltage, but most people probably don't have to use that function. And there's percent duty cycle as well. And some meters can measure minimum and maximum and average values, and really advanced stuff like that. But that's probably beyond this video. And they also come in 2 basic types. One is an average responding AC meter, and another one is what's called true RMS. And you'll almost certainly find true RMS written on the front somewhere. It's not written on this Fluke 101 here, so this is what's called average responding. So if you're measuring AC voltage or AC current, and that's the only thing that true RMS applies to, if you use a non-true RMS meter like this, which is called an average responding meter, then you're only going to get accurate AC readings for a complete sinusoidal waveform like you'll get on your mains 110 or 240 volt power supply. Any other AC signal that's not sinusoidal, it won't be accurate, and that's where a true RMS meter is going to be more accurate. But for most purposes, if you're watching this video, true RMS, it's nice to have, but it's not really that important. Now let's go on to some practical uses of your multimeter. You always want to plug the black jack into the COM or common terminal here. It always stays in that terminal. And your red lead for all measurements except for current over here. So for your ohms measurement, continuity, voltage, hertz, temperature here, diode testing, capacitance, everything, you want to plug your red one into your positive there. With your probes plugged into the positive voltage jack and the common terminal like this, it presents a very high impedance load across anything that you're measuring. Modern multimeters are designed to be very well protected. So you can see I've got it plugged into 240 volt mains here, and it doesn't matter if we accidentally select ohms, it might flash and beep at you, or millivolts or diodes or capacitance. Even if you switch accidentally to amps or microamps, it's not going to be a problem. You're generally speaking not going to damage your multimeter. They're fairly robust. But here's where it can get dangerous for the thing you're testing, or for your multimeter, or for yourself. If you plug the positive lead into your microamps, milliamps, or amps jack over here, what you're doing is essentially presenting a short circuit across here. Now these current inputs are usually fused, so you can see it's got a 10 amp max and a 600 milliamp max rating, and the fuses are in the back of the meter and you can replace them. But once you plug them in, you can short out things. So for example, you don't want to go testing your mains voltage with your lead accidentally plugged into either here. And this is why some multimeters have what's called an input jack alert here. So if I've got it set to voltage, which is the incorrect thing for measuring current, it'll tell me insertion error, it'll beep at me. Not all multimeters have this, but a nice function. That just reminds me as a safety feature that I've got it plugged into here, and I should actually select amps. And it puts your mind in the correct mindset of, right, now this is potentially dangerous if I measure a voltage while I'm in the current measurement range. And if I plug the probes into another multimeter measuring ohms, you can see that it's basically a short circuit, 0.2 ohms there across that. It'll be a little bit higher for the milliamps and microamps range here, 3 ohms. So just be very careful about that. Before you test, make sure your probe is in the voltage range unless you absolutely know you're going to measure current. So the last thing you want to do is blow up your multimeter, release the magic smoke, or blow up your fuses, or damage the product that you're actually trying to test. That is why a simpler meter like this that doesn't have any current ranges is technically safer, because it doesn't matter what you plug it into, you're not really going to blow this thing up or blow up any of the circuits that you're measuring, but you don't have the flexibility of current measurement. That's just the price you pay. Another important safety thing with multimeters is what's called a CAT rating. And you can see that it's generally written on the front here. This Fluke is a CAT 3. This EEVblog Brymen meter over here is up to a CAT 4. And this just $2 cheapie manual ranger over here is a CAT 2 rating. I won't go into the complexities of that, but suffice it to say, if you're going to be doing any mains electrical measurement or any industrial electrical measurement at all, you want at least a CAT 3 rating on your input. I wouldn't recommend using a CAT 2 multimeter on a 240 volt mains, for example. You can do it, but it just means that the multimeter doesn't have as good a protection circuitry inside as a CAT 3 or CAT 4 rated multimeter. CAT 3 is plenty for anything you want to do with anything mains rated. And here's an example of those fuses inside the multimeter. Sometimes you've got to take the whole back off, other times they'll be inside the fuse compartment, and these are what's called HRC fuses. These white ones, they're actually ceramic fuses, and if you're serious about your like mains testing and safety and high energy systems, then you want HRC fuses. A lot of your cheaper multimeters won't actually have that. Here's inside this cheap $2 multimeter. It's just got one of these crappy glass fuses in it. Not that great. Kind of sort of does the job, but no, for any high energy measurements, any electrician wouldn't be caught dead using one of these meters. And if you care about multimeter safety, then a lot of the big brands will actually have independent third-party safety testing on them, either through Underwriters Laboratory UL like this, or through ETL. So if you see either of those marks on a multimeter, then you know it's been independently certified for safety. And by the way, just be careful with storing alkaline batteries in your multimeter if you don't use it that often. This one has begun to leak. Look at this. So yeah, alkaline battery leakage, very common in equipment that you don't use that often. Oops, I've come a gutter there. And when you're measuring ohms here, generally, you don't want to be measuring ohms in circuit unless you absolutely know what you're doing. Like this resistor that I'm measuring now is supposed to be a 10K resistor, but you can see it's measuring 3.6K resistor because it's in circuit, and the test current that comes out of here can go elsewhere in the circuit. You don't know where, and that can upset the reading on the meter. But if you lift one end of the resistor out like this, then you can actually properly measure its value. There it is, 10K. So as a general rule with resistance, don't try and measure anything in circuit unless you absolutely know what's happening in your circuit. And even then, you can come a gutser. Don't do it. Now, some meters have an auto hold or touch hold function, as it's called. And if you enable that, that can be really handy for like really tricky probing things. So if I just probe that briefly, it locks in, and then I take my probes away and the reading is still there. It's locked in for me. So it basically waits for a stable reading, and then once it's found it, it locks it in for you. Very handy. And then it's ready to go again. If we get another battery here and we probe that, then it's locked in, it beeps, and then it flashes that reading, and it's hands-free. So not an essential feature, but it's pretty darn handy. So your DC voltage mode is handy for measuring, as the name says, DC voltages. So that's that symbol up there. And of course, batteries is a classic example. It could be a 9-volt battery, a AA, AAA, or D-cell battery like this. It could be one of these lithium-ion or lithium polymer batteries like this. So you can just put your probes on there. Be careful you don't short it out, because these have a lot of metal on them. So if you put it on a high-capacity battery and you accidentally short out your terminals, you can come a gutter. You don't want to be shorting out your battery, so just be careful that you don't slip. But there you go, you can measure those, you can measure coin cell batteries, you can measure your car battery or whatever, and it doesn't matter if you get the probes back to front. It'll just show a negative there. In fact, that's a handy feature to know which way around the voltage is. So you can't damage the meter or the thing you're testing by getting the probes back to front. DC mode is also what you want to use to measure plug packs, for example. It'll have, say, 12 volts DC. You can see the tiny little DC symbol written down there. So this is the 12-volt plug pack. Let's measure it. So I've plugged it into our mains here, and there you go. We can just probe in there like that. And it's handy for measuring whether or not this is a center positive or center negative. For example, we plug our positive probe into the center and it reads positive on here, then obviously this is a center positive. And then if we want to select AC mode, we can press select here. VFD is for variable frequency drives. That's just another feature which I won't go into. And we can measure our mains. As I said, very handy for doing that. Just be careful that you don't touch the probes in any situation like this. It's best to leave, in this particular case, it's just one hand behind your back and probe like that. Because if you put one end in like that, then this other end has become live. So just be aware of that. You might come a gutser and that'll ruin your day. Very dangerous. I'll show you an example of doing a current measurement. The thing with current measurement is that you have to measure it in series with the circuit. So you have to break your circuit in order for it to work. So let's take this fan, for example. Let's connect it across our battery here, and the fan starts blowing. Now, if we want to measure the current that's flowing through that circuit there, very simple, then we need to break the circuit like this, then plug our positive lead into the current jack here. It's going to warn us that we need to turn it to current mode. Thank you very much. So we're now in DC current mode here, milliamps. So we want to put our current meter in series with this circuit. So we'll put it onto the positive terminal like this, and the negative terminal over here, we'll plug it onto the positive terminal of our fan, and then we can connect up the negative terminal, and once again, it's going to blow, but it's going to show that we're drawing 150 milliamps there. And just like voltage, it's not going to be fussed if we get our polarity back to front like this. So we switch that over and we plug that into there, and we get minus 150 milliamps. We're not going to damage anything, we just know that we've plugged it in backwards. It's going to read the same. So we can't use a multimeter to measure current in circuit. You can't just go probe around your circuit and measure current. You would have to, say, break one of these links, for example, cut it in half, and then put the probe either side to measure the current flowing through that link. Or you would have to break one of the circuit traces on the bottom. So you've got to put your multimeter in series for current. Like I said, your average home handyman or user of a multimeter is probably not going to have a call for measuring current. So don't worry if you don't have that feature. And for capacitance mode, which is that symbol there, so we go over to capacitance, measured as in farad, generally, although not always, you can actually measure things in circuit. This is a 100 microfarad capacitor, and it's measuring 95 microfarads, so you know it's probably okay. Great for troubleshooting power supplies, for example, because capacitors contain electrolyte fluid, which can actually leak out, and you can get bulgy capacitors, and that's what that vent is in the top. If there's pressure build up in there, it can all leak out, and your capacitors can fail. Very common failure modes, so very useful for troubleshooting and repairing power supply electronics, for example, as well as measuring capacitors in engineering uses. Another use for the capacitance meter is to measure breaks in long cables. So I'll zero out the capacitance of the leads here with the delta function like this, and I'll measure this coaxial cable here, which is 10 meters long. Careful not to put your fingers on both of them at the same time. There you go, 2.66 nanofarads for 10 meters. Now what happens if I put a break in that at, say, 2 meters? So if this cable was broken at 2 meters, you'd expect about 0.5, 0.53 nanofarads. That's not too far off, is it? And sure enough, at 2 meters, I've broken the cable. So you can get that specification, the cable capacitance, possibly from the data sheet, or you can actually measure it. Once again, handy little function for capacitance. And of course your ohms measurement is very handy for cable measurements as well. So if we measure the outer shield there, we can actually test that that outer shield is connected. There you go, 0.6 ohms. So, and then we can test the inner conductor like that. And I'm not getting good pressure on there, but anyway, 1.3 ohms. And that's the thing, when you're reading very low ohms, like, you know, sub 10 ohms or something like that, the lead resistance is going to matter. So having sharp points is very useful for getting through any like oxide coatings on contact. So if I just loosely short those out, like, yeah, it's not terrific, right? 1 ohm, something like that. But if I really put pressure on there, then it's going to be like 0.1 ohms. And you can also have a zero function or a delta function. And most auto-ranging meters will have a manual range override button here. So we're in the 6 volt range at the moment because this is a 6,000 count meter, so 6,000 maximum. And so we get 5 point and we get 3 decimal places after that. So if we press that, we go into manual ranging, and you'll notice that the auto up the top has disappeared. And then if we press that again, we'll go into the 60 volt range. So you'll notice that we lose a digit of resolution here, it's called. And then we press it again, and we can go into the 600 volt range, and once again we've lost another digit. And then we can go to the 1000 volt range. This won't go to 6000 volts, 1000 volts maximum, and then we can go back and bingo, and then we can hold that down and go back into auto. Sometimes that's handy, and you'll generally get a faster response in manual ranging mode, and it won't like hunt, because some meters are slow at auto ranging, but it's still better than a manual ranging meter. And some meters will have what's called a bar graph on here. So it's got the bars like this that actually show you from 0 to full scale. In fact, this is a 6,000 count meter, so it goes up to 6 in this case because we're on the I'm on manual ranging there. And you'll notice that the bar graph will update somewhat quicker than the readings here. Typically you might get 10 or 20 times per second updating on the bar graph. It's faster, but there's less resolution on there than the main display. This is a pretty quick updating main display meter, but the bar graph is quicker. It is designed to simulate an old school analog meter like this, where the needle meter movement moves like that. That's what they're designed for. Not an essential feature, but handy for some people. So there you go. I hope you enjoyed that guide to multimeters. And as I said, there's more advanced ones which have like menu systems and lots of extra buttons like these on them. They can do a bit more stuff than your average multimeter, but yeah, you don't have to spend much on a multimeter. Now, bias, of course, I actually sell my own branded multimeters. They manufactured by a Taiwanese company called Brymen here, so I'll link them in down below. This is a very nice $100 class multimeter, which will do you for, if you're watching this video, it'll do you for almost everything. It's independently UL listed, it's very safe, it's Cat 4 rated, it's very fast responding, nice continuity mode, etc, etc. So this would be an example of an excellent multimeter for an electrician, for example, or for, you know, basic electronics engineering use, but you don't have to spend $100. And this Fluke 101 multimeter, for example, it's like, you know, $50 or $60 you can get this for, and it doesn't have current measurement, of course, but it's a very nice little compact rugged meter. Or if you want to go cheaper again, this ANENG 8008, for example, it's a $20 multimeter. I'll link in a video down below where I've done a full review on something like this. So, you know, you don't have to spend more than $20 if you don't really want to. Of course, it's not up to the same quality as something like this, but it's a decent meter and gets the job done for like 20 bucks. And like I said, you can get a $2 one, but yeah, okay, if you want, it'll get you out of trouble, but, you know, I'd recommend spending, say, 20 bucks at least, but, you know, spend 100, 200, 500, whatever you like. Anyway, I've done lots of multimeter review videos. I'll link them in down below. Anyway, hope you enjoyed that video and found it useful. If you did, please give it a big thumbs up, subscribe down below, and also I'll link to my EEVblog.store where you can buy my own branded meters down there, or my merch, or whatever. And you can check out the EEVblog forum down below. It's where all the nerds hang out and talk about multimeters. They just love them. Catch you next time.